Welcome back. In this video, our objectives are to find the compositions of functions. So we are going to be working with one function that's going to be placed inside of another function and evaluated. And if you do any kind of computer programming, you will see this quite often. Okay? So a composition of function is denoted with this f of g, or f of g of x. So we've got the open dot here, not to be confused with a closed dot, which might symbolize multiplication. Although with multiplication, generally there's nothing in between the f and the g, or the names of the two functions. So, and the book gives us a nice example here of the definition. The domain of f of g is the set of all x in the domain of g, such that g of x is in the domain of f. Let's take a look at a sample of this. That might be a little bit easier. So, given our two functions, f and g of x, find the following. Find f of g of x. So we're going to work from right to left here. They're saying put g into f. So we're going to place g into f for x. So we're going to take our g function, 2x squared plus 2, and we're going to put it in to the f function for x. So we get 3 times 2x squared plus 2 plus 4. So here is our g function. So simplifying that, we get 6x squared plus 6 plus 4. So we get 6x squared plus 10. So f of g of x equals the function 6x squared plus 10. You may also see g of f of x. So now we're going to place f into g for x. So we're working in the opposite direction. We're going to take f and we're going to plug it into g for our x value. So we get 2 times 3x plus 4, quantity squared, plus 2. So following our multiplication pattern, we get 9x squared plus 24x plus 16 plus 2. We've got to double that entire quantity. So we get 18x squared plus 48x plus 32 plus 2, or 18x squared plus 48x plus 34 is g of f of x. And then finally, they're asking us to find f of g of negative 2. Well, we've already found f of g from above, right? We saw that was 6x squared plus 10. So all we need to do is replace our x value with negative 2. So we put negative 2 in for x and square it and solve. So we get 6 times 4 plus 10, or 34. Now there is an alternate method for doing these kinds of problems. To find f of g of negative 2, we can work backwards. We can find g of negative 2 and then take that result and put it into f. So if we wanted to find g of negative 2, our g function was 2x squared plus 2. So it was 2 times negative 2 squared plus 2 would be 10. And then we would take 10 and place it into our function for f. So our f of 10 is 3 times 10 plus 4. And indeed, we get the same result, which we should. Here's another kind of problem you're going to see. We're going to write a function h of x as a composition of two functions. So we're going to split this function into two separate ones. So what we want to do is we want to look for an inner, if you will, and an outer function. So we want to try and find two expressions here, and then use our composition of functions to combine them into one. Now there are multiple correct answers here, but I do see like this x minus 2 could be an inner function. So we could say that we have this function, we'll just call it f of x, could be x minus 2. Well, our other function then could be 1 over, say, x squared, right? Because this is our whole inner function, all right? So we could have a function g of x that would be 1 over x squared. So if we put x minus 2, if we put f of x into g of x, we would get our answer here. So we could say h of x could equal g of f of x, because we put f into g and we get that particular answer. So we have successfully rewritten that as a composition of two functions. So there's our introduction to the composition of functions, and you'll get some more practice with that when I see you in class.